Hello again. I hope you all are doing well. Thank you for watching. In this little video we will discuss combining functions with our basic operations. I will do another video about function composition, which is another way to combine functions. But I'll just make a separate video for that. So this one will just cover the basic operations, meaning add, subtract, multiply, and divide. All right, and you'll find, I think, that it's pretty easy. So let's take a couple of functions that I've just picked out kind of at random. F of x equals 2x minus 3, and g of x equals x squared plus 2x. So we have a linear function and a quadratic function, and we'll see what happens when we use our basic operations to combine these. And so it's probably as simple as you may hope or may have already seen or thought about. But if we had the situation where we had to add these two functions, together, so f of x plus g of x, you might see it written like this, or you might just see f plus g. That's two different ways that really mean to do the same thing, and it literally just means to combine all your like terms. So 2x minus 3 plus x squared plus 2x. And so you finally end up with a new function, x squared plus 4x minus 3. So we added a linear and a quadratic, and we ended up with a quadratic. Okay, that's adding functions, just combining like terms. Subtracting is also just about combining like terms. For example, if I just said, let's do g of x, let's just say g minus f. All right. All that means to do is take g of x, x squared plus 2x, and subtract f of x. Yes, couldn't be more obvious, I suppose. The only thing you might want to think about here is putting the function that is to be subtracted in parentheses. That way we are very careful about distributing the negative sign to everything in that function. So as you can see, we'll have the x squared. Then we have 2x minus 2x, that's no more x's. And then we have the subtracting the negative 3. It means we're going to end up with x squared plus 3. So subtracting a linear function minus a quadratic function minus a linear function gives us another quadratic function. So what about multiplying? Multiplying two functions together, sometimes it's a little bit more work, but conceptually it's really no different. If I take f of x times g of x, f of x times g of x, something like that. Or you might just say fg. Either way, it means the same thing. And yeah, well, that's all we do. We're going to multiply these two things together. And, depending on the function itself, that could be a little bit more complicated, but the procedure is really, it's pretty obvious, I would hope. 2x times x squared is 2x to the third, and then 2x times 2x gives me 4x squared. And then now I'm going to go negative 3 times x squared, so that's negative 3x squared, and negative 3 times 2x is negative 6x. So my final function as a result of multiplying those two functions together is 2x cubed plus x squared minus 6x. So this time we multiplied a linear times a quadratic, and we ended up with a cubic. So that was interesting. Let's think about our final operation here, division. Not really anything else going on here. In these two functions, if I wanted to divide f divided by g, for example, that just simply means 2x minus 3 over x squared plus x. And anytime we have a rational function such as this, the other concerns that we have about that are no different here than they are in any other case. That is, if I can factor or simplify the expression, that would be good. In this case, cannot be simplified. I can factor out an x on the bottom. I can say, this is x times x plus 1, but that doesn't really help me simplify the fraction at all. It just means the bottom is now factored. So it didn't help me simplify. However, it did allow me to identify the other feature of a rational function is that since it is a one function divided by another, we have to make sure that we are not dividing by 0. So this factoring the denominator here did allow me to easily identify the numbers that make the denominator equal 0. So the domain for this, you might call it just the domain, x cannot equal 0 or -1. Because if it did, then we would be dividing by 0. But that's really the only other possible little wrinkle that you may run into in dividing two functions. Okay, so that's it. The basic operations on function combinations here. Addition, just combining like terms. Subtraction, also combining like terms, but don't forget about putting the function that is to be subtracted in parentheses. That helps you be accurate there. Then multiplying, nothing really different there, just multiplying two expressions together. Same with division, just be careful of the denominator not equaling 0. And if you can factor and simplify, then that you should do. Okay, next video about function combinations. See you there. Thanks. Bye-bye.